Okay, welcome back to design tutorial for this week. So we're going to be going over how to kind of start and set up a design in Fusion 360, and also how to make basic gears, because they're pretty simple. There's just a tool that does it, and we're kind of going to meld those two ideas into one day. So this is what Fusion will look like. You'll have all your previous designs. I have plenty. You probably won't see this many. That's okay. On the left side here, you're going to click New. And now out of these 6 options, I'd highly recommend hybrid design pretty much 99% of the time. What this means is in Fusion 360, there's kind of 2 different types of models. There's what's called a body, and that's what this part design will be. And it lets you build kind of one component. So it's kind of one solid piece, but it doesn't let you move it or relate it or conjoin it with any other pieces. You're not allowed to have any relationships between them. And assembly doesn't actually let you make any parts at all. It only lets you combine individual pieces from this one. So it doesn't let you create a sketch or extrude or make any component at all. Hybrid lets you do both. So I pick hybrid every time. I'd never pick these two because even if I am just making one part, which this one would be useful for, sometimes in the future I want to add another part to it or rename it or kind of group it differently, and you can't do that because you're only allowed to build one kind of piece in this part design. So click hybrid, click create. That'll open up a new blank document, and then obviously at your top you have your basic tools. For gears, there's a tool, so you're going to want to go to utilities, add-ins, and you want to click scripts and add-ins. This window will pop up. And if you scroll down, there should be one called spur gear. Now, you're going to want to click this little button here so that it's on all the time. And what that'll do is it will put it up here in the solid frame. And then when you click create, you'll see spur gear down here. So hover over create, you'll click spur gear. If you have that turned off in this utilities tab, it won't be there. You also want to click run on startup. Back to the solid tab, we're going to click spur gear. And this is where things get interesting. So you can name it whatever you want. Ideally, you name it the default that it says. External, internal. External just means that it'll kind of create a separate document with just the gear and then put it in here. So it'll be like its own document. If you want that, cool. I've never done it, so that's okay. Module is like the size of gear. So let's say we're talking about shoe sizes. So this would be like a size 12.7 gear. And the module kind of depicts how big the gear is. For most of the gears in the robotics team, I have done module 3 for all the ones we've printed so far. Some of them need to be super specific. You could make this number as many decimals as you want. You could make it this module. Ideally, you want to pick 3, maybe 5. We're just going to do 3 to kind of show you what it looks like. Number of teeth, pretty obvious. It's how many teeth you want. You could go 5. You could be 15. You could be 170, 180. Down here, it'll tell you any errors that are happening. We'll get to that in a second. So number of teeth is big. Module is big. You shouldn't have to change either of these 2 things. Metric is fine. Ideally, you don't want it on English because everything else that's already 3D printed that we have is in metric. Pressure angle, also just keep it at 20 degrees because that's been the standard for what we've done for the past couple of years. Backlash, 0 is okay. Root fillet radius, as you can see, it's up here. It's a little curve inside here. Usually, it has to be quite small. I always set it to 0.5. Sometimes if you're making a huge gear, you can set it bigger if you want. You can also set it to 0 if you want a sharp corner, but it won't print as quickly on the printer. By like a minute, so it doesn't really matter. But usually you want to keep it there just so there's no weak points. Gear thickness and hole diameter are the 2 things that you kind of really want to pay attention to. So gear thickness obviously is how thick the gear is going to be, how thick it's going to end up. Most of the time I do 7 or 8. It's pretty thick, it's pretty strong. It can be like a millimeter or so out of alignment and it'll still work really well. 10 is kind of a waste of filament, like a full centimeter thick is quite thick. If you go like below 5, they're really hard to line up with each other unless you're making really tiny gears or they're screwed onto like one specific component. Especially if they're going to be gears that are going on the robot itself, then I'd definitely make them thicker just for strength reasons. But if you're making, a controller or something else, or maybe you're just using gears for not a robotics project, then pick whatever size you like. But I usually go with 7 or 8, so we're going to go 8. Hole diameter is the center hole. Now, this is kind of going to be one of 2 things. If you're going to put a bearing in this gear, say it has to spin because it's connected to 2 different gears or some other reason, you want to set it to the size of the bearing. Usually, though, these gears are going to have a hex shaft through them. So usually I set it to 0, and that'll just make no hole through the center. Now, that's all good. We've got our gear. Now, how actually big is the gear? Because when we make 2 gears next to each other, we care about this pitch diameter. And what the pitch diameter means is when you have 2 center points of the 2 axles that the gears are on, the pitch diameter is the size you want the gears to be. And you get that from measuring the center point between the 2 axles. Yeah, whatever 2 axles you're putting the gears on, you want to measure between them. let's say it's 80 millimeters, you want your pitch diameter to end up being 80 millimeters. So what I do is at module 3, I'll just move my number of teeth until it says 80. So 50 is too much. Let's try 40. Still too much. Let's go 28. Close. We're going to go 26, 27 teeth, 81. That's pretty close. I would go under because nothing we make is super exact, so that's probably okay there. If you do want it to be exactly 80 millimeters and you're making 2 gears specifically for this one project, you can always increase the module here by random increments until you find the right one. So 3.07 is 0.2 millimeters off. That's really close. I don't like doing that though, because I kind of want all these gears to fit together. And ideally you want the gear to be a nice round number, and then you change your axle position to fit the gears that you want. And 2 millimeters is really close. So that's going to be good enough for what we need. And that's pretty much it. So 78 millimeters, again, that's the distance between the 2 center points of the 2 axles that these gears are sitting on. The module is just kind of like the shoe size of the gear. How big is it generally? You shouldn't have to mess with these 2 top ones here. Yeah, so just to cover, module shoe size, number of teeth is kind of how big the gear is going to end up being. Thickness is your strength pretty much, and hole diameter is whether you want a bearing or a hex shaft or whatever's going to go through the center of the gear. And that's pretty much it. So we're going to click OK on that, and that'll make our gear. And you can see it's kind of made itself a little component here, so you can kind of see how they made it. You can jump into the first sketch, you can jump into the second one where the teeth is made, you can jump into the fillet, which is where we set that 0.5. Circular pattern just copies it those 26 times that we set, and you can see this little sketch line here. If we measure that, it will be our 78 millimeters on the right here. 78 millimeters, perfect. Which means if we grab this and we copy paste it a perfect 78 millimeters over, you can see that that's the perfect distance. Now it looks a little weird because the teeth are kind of inside of each other. To fix that, if you want to fix that, you can rotate the gear along its center point a little bit, like -1 degree, maybe 5 degrees, 7 degrees. There we go. That's pretty close. Again, this is just for looks. When you print these, obviously it won't matter. And there's your gear. To recap kind of everything today is when you make a new design, select hybrid every time. And then make sure your add-in is turned on up here in the top. And then when you go back to solid, it will be right here in spur gear. That's how to make gears. Hopefully learn something. Please try it out on your Fusion at home. You can download the software for free on your home computer or during class. That's it. Welcome to Gears.